Hello everyone. We have a question which says that coplanar forces of magnitude 24 Newton, P Newton, 20 Newton and 36 Newton act at a point in the directions shown in the diagram. What are coplanar forces? Coplanar forces are the forces which act at just one single point, and if we just look at all these four forces, 24 Newton, P Newton, 20 and 36 Newton, they all are acting at this particular point. That means all these four forces are coplanar forces. According to the question given that sine alpha is equal to 3 upon 5, find the value of P and theta. And they have also given us a condition in the question in the second line that the forces are in equilibrium. That means the system is in equilibrium, and when we say that the system is in equilibrium, that means the opposite forces are equal. And opposite forces are equal means the opposite horizontal forces are equal as well as the opposite vertical forces are equal. For that, definitely we have to split up the components, the horizontal components and the vertical components of the given forces. But before that, we should understand what the components are. I have seen that most of the students have a misconception that the horizontal component is always a cos component. No, it is not like that. It depends upon the angle. If the angle is over here, then the side next to that would be a cos component of that particular force, and the opposite side would be a sine component of that particular force. But if in the diagram the angle is given over here, then the side next to that would be a cos component of that force and the opposite side would be a sine component of that particular force. That means it depends upon the angle where the cos and the sine component would lie. So if we just look at the diagram, we can see that I have split it up the horizontal as well as the vertical component. This 20 Newton is purely a horizontal component because we can see a 90-degree representation over here. That means no vertical component for this 20 Newton. And this P Newton is making an angle theta degree with the y-axis, not with the x-axis. And we have just seen that the angle next to the side next to the angle is always a cos component. That means this vertical side would be a cos component because the angle is with that side. That means this would be P cos theta and definitely this would be P sin theta. Similarly, 24 Newton is a force, and over here also the angle alpha is with the y-axis, not with the x-axis. That means the side next to this alpha would be a cos component side. That means the vertical would be cos component, as I have written over here 24 cos alpha, and definitely this side over here from here till here, if I draw a line, that would be 24 sin alpha. And the same goes to 36 Newton making an angle alpha with the y-axis. So this vertical side would be a cos component pointing downward, so that would be 36 cos alpha, and definitely this would be 36 sin alpha from here till here. Now as we can see, we have all the components, the horizontal component and the vertical component, and the condition is that the system is in equilibrium. That means the opposite forces are equal, so we will split it up into horizontal and vertical. But before that, definitely it is given over here that sine alpha is 3 upon 5. If we just look at all the horizontal and the vertical component, we can see that at some places there are sine theta, at some places there are sine alpha and cos alpha as well. Theta is basically the value to be found, but definitely alpha, sine alpha, they have given us over here 3 upon 5, but we don't have the value of cos alpha. So we will use this value of sine alpha to find the cos alpha, and for that definitely we will draw the diagram the right angle triangle, and this sine alpha is 3 upon 5, at 3 is representing opposite and 5 hypotenuse, because we know that sine is opposite upon hypotenuse. Opposite is 3 over here, hypotenuse is 5 over here, and by using the Pythagoras theorem we could easily calculate the third side. That means by simply squaring the hypotenuse and subtracting the opposite, subtracting the square of the opposite side and then taking the square root, finally we can see that yes, the adjacent is 4, and with the help of that we could easily write that cos alpha would be 4 upon 5, because cos alpha is adjacent upon hypotenuse 4 upon 5. Now because we have sine alpha, we have cos alpha, now we could directly work out with the horizontal forces and the vertical forces. Again, let me repeat, the condition is an equilibrium. So looking at the horizontal forces, we have two horizontal forces to the left and two horizontal forces to the right. Condition is equilibrium. That means the sum of these two would be equal to the sum of these two. So 24 sine alpha plus 36 sine alpha, I have written over here, would be equal to p sine theta plus 20, I have written over here. 24 sine alpha plus 36 sine alpha is 60 sine alpha, is equal to p sine theta plus 20. We know the value of sine alpha over here, 3 upon 5. Just place it over here, move this 20 on that side and subtract it, simplify it, and we can get the value of p sine theta is equal to, and from here after simplifying we have 16. So this is an equation 1 from the horizontal forces. We will create another equation from the vertical forces, and we have the components in the diagram. The vertical forces, as we can see over here, p cos theta and 24 cos alpha pointing upward and 36 cos alpha pointing downward. The condition is an equilibrium. That means 24 cos alpha and p cos theta would be equal to 36 cos alpha. We have the value of cos alpha, we have the value of cos alpha. We could place this 4 upon 5 and then definitely simplify it. So p cos theta over here would be equal to 36 cos alpha. Moving that on the other side, minus 24 cos alpha. 36 minus 24 is 12 cos alpha, and 12 multiplied by cos alpha, which is 4 upon 5. After simplification it would be 9.6. So p cos theta is 9.6. A second equation. Now we have two methods to solve this particular and get the value of the unknown, which is p and theta. So the first method is dividing the equation 1 by 2, because equation 1 is in the form of sine, equation 2 is in the form of cos. So dividing equation 1 by 2, that means sine upon cos. We could cancel this p, and sine upon cos would be tan theta, and over here this is 16 and 9.6, because when we divided p sine theta divided by p cos theta, it would be equal to 16 divided by 9.6. And we have 1.666, cancelling the p, sine upon cos is tan, so tan theta is 1.66. Taking the tan inverse of 1.66, we can find the value of theta over here, which is 59 degree. Placing this value of theta in any of the equation, whether equation 1 or equation 2, so that we could find the value of p very easy. For example, if we take equation 1, which is p sine theta is equals to 16, so over here p sine theta is equals to 16, so 16 divided by sine theta, and theta is 59, so 16 divided by sine 59, and p is equals to 18.7 Newton. So this method is super easy. We do have another method, that is squaring and adding equation 1 and 2. If we square first and then add equation 1 and 2, that means p cos theta and p sine theta and p cos theta, if we just square them and add them, and that would be equal to 16 square plus 9.6 square, and after simplifying 16 square plus 9.6 square, it would be 348.16. and from here, after Opening up the bracket, it would be p square sine square theta plus p square cos square theta. Taking p square as common, we are left with sine square theta plus cos square theta inside the bracket, which is an identity equal to 1. So we are just left with p square equal 348.16. Taking square root on both sides, and we have finally p is equals to 18.7, which is the same answer that we got from method 1. And now placing this value of p in any of the equation 1 or 2, if we place it in equation 1, which was 9 p sine theta is equals to 16, placing this value of p over here, so sine theta would be 16 divided by p, and 16 divided by 18.7, because p is 18.7, we have 0.8556. Taking the sine inverse of 0.8556, we have theta is equals to 59 degree, which is the same answer that we got from the method 1. Both the methods are super simple and easy. You just have to apply any one to get the answer.